Chapter 15, Random Variables is the title. So this unit, this chapter does not need to be, let's make sure we're focused. It can be challenging because it's kind of new and you don't have a ton to draw on from past experiences. But it's really only 2 formulas, 3 formulas, okay? And a matter of just applying them, okay, and understanding them conceptually, all right? Let's start with what is a random variable. A random variable assumes a value based on the outcome of a random event. So all a random variable is a variable where you don't know the exact outcome. The outcome comes from some random event. We've already kind of looked at these a little bit with our last few chapters, like the problem where when you pull up to the red light, to the light, is it red, yellow, or green? That's a random variable. Its outcome is a random event. You don't know what the outcome is going to be. So we're just kind of formally calling these variables and starting to let letters like X actually like equal the event. Okay, so we're just putting more of a formal name on kind of what things we've already been looking at. We usually let capital X's to denote a random variable, and then we let a lowercase x represent a particular outcome of that variable. So, for example, if capital X equals the color of the light, then we would have a little x of green, a little x of yellow. These would all be different outcomes, or a little x of red. And then I could write, write probability of x, and I'm talking about one of these. Not all at the same time, though. We would have different events, okay? There are 2 types of random variables, discrete and continuous. A discrete random variable can take on one of a countable number of distinct outcomes. Really what the difference between these two is discrete, your answers could be like 3, 4, or 5, or something like that. Continuous, they could be any number from 3 to 5. So like it could be 3.1, 3.2, or it could even be 3.11. Or we could even go 3.00001. Like continuous means it can take on all the values in between. Discrete means it kind of skips from number to number. So like number of credit hours, you take, like in high school, you take 1 credit hour or 2 credit hours, and there could maybe be a half of a credit potentially, but there's not 1.1 or 1.2. You don't have all those little decimals. I don't know if I love this example, cost of books, but something like amount, a lot of things you measure. Amount of gasoline in your tank. Something like that would be a continuous random variable. Imagine as you're filling up your tank with gasoline, it doesn't go from 1 gallon to 2 gallons. It goes through all your heights. When you grow height, when you go from 50 inches to 51 inches, at some point in time, your height was 50.5. Do y'all understand that? You have to go through all of the increments in between. All right? So basically what the difference is here is for discrete, we're going to be making tables and calculating mean and standard deviation from formulas for discrete. We're going to be making tables and calculating means and standard deviations from formulas. For continuous, we are provided means and standard deviations. We don't have to calculate those means and standard deviations. We're provided with that information, and then we're just going to use them to finish the problem. Yes?
So would it be okay to assume
No. Yeah, no, I mean, in your brain, you could categorize it that way, but they don't have to be whole number. Like, they're just distinct outcomes. Like, we're going to look at one in a minute where you might, wi- like, win a coupon or something like that, and it's the value of the coupon. So if the coupon's $2.50, then it's not a whole number. But it's just distinct outcomes, and it doesn't, yeah, right. Like rolling a die. That's a discrete random variable. You get a 1, 2, 3, 4, 5, or 6. Period. Flipping a coin. That's a discrete random variable. Pretty much everything we've been looking at for the last chapter has been discrete random variables. Very distinct outcomes. Okay. You'll see. We're going to focus on discrete first, and then you'll see the difference with continuous. All right. So we're going to be making probability models in this chapter. This is kind of new. You made tables last chapter. That tables really went for 2 variables. We really only going to be dealing with 1 variable here. So it is like a table. We call it a probability model. This is a collection, and we're talking about discrete here. We're talking about discrete now. This is a collection of all possible values of a random variable. So that's why it would be for discrete. We can't list all the outcomes for continuous. There's an infinite number. Do y'all get that? Okay? Discrete, distinct outcomes. We can make a probability model by listing all the possible outcomes and listing the probability of each one of those outcomes. Well, one thing we're going to be finding is the expected value. The expected value for a discrete random variable, we use E of x or we use mu, and this is really the same thing as the mean or the average. Okay, keep that in your head. All this really is the average, the mean, the expected outcome, the middle ground. All right, there's an actual formula to find the expected value. Here it is. I know y'all are still not really getting used to some of these symbols, but you need to get yourselves used to what this is telling you. So on the left, and this is on your formula sheet, it is the next formula on your formula sheet after the conditional probability formula. It's the third formula on the right-hand side. So the left-hand side, don't be confused with this. This is just telling you that mu and E of x are the same thing. There's just 2 different symbols we use, mu or E of x. You can write whichever one you want. You need to be okay with either. But this is the actual formula. Now, can somebody tell me what this is telling us to do? What's the little sigma mean? No. No. This E. They're kind of, they look alike. This means like this is expected value, which is sort of like the mean. This is the Greek letter sigma, which means sum. So we're going to add up. And then what do y'all think these means? What's a little x? The outcomes, all the outcomes, and we're going to multiply that by the probability of that outcome occurring. And so you're going to take each individual outcome, multiply by its probability, and then add them all up. And that is how you find the mean, the average. Does that make sense a little bit? It should kind of make sense to you. Make sure, this is important, that you have every possible outcome in your probability model. You can check that by adding up all your probabilities. If you have all the outcomes, then all the probabilities should add up to 1. Okay? So that's important. And here is an example. A local restaurant offers a Lucky Lover special on Valentine's Day. If we were doing this in a year-round course, we always hit this question right around Valentine's Day, but it's not. We're in block, so it's not as much fun. So this whole PowerPoint, or it's not a PowerPoint, but it was at one point. All of these notes for this chapter kind of go back to this problem, this scenario, okay? So, and if you read the book, I think it's in there somewhere too. So a local restaurant offers a Lucky Lover special on Valentine's Day. When the waiter brings your check, he'll also bring the 4 aces from the deck of cards. So we have the ace of hearts, we have the ace of clubs, we have the ace of spades, and we have the ace of diamonds. Those are the 4 aces from the deck of cards. The couple will then get to turn one card over. If it's a black ace, they'll owe the full amount. In other words, they don't get a discount if it's a black ace. This is Valentine's Day, so we're looking for love, red. There's. This is ace of hearts. Spades. Oh, I see. Took me a little while. I got it. We're good now. All right. So for the 2 black aces, which would be these 2, right? Y'all agree? They get no discount. Okay. Let's keep reading. They'll owe the full amount. But if it's the ace of hearts, the waiter will give them a $20 Lucky Lovers discount. So they're going to get $20 off their meal. Woohoo! If they turn over the ace of diamonds, hey, at least it's red, they'll then get to turn over one of the remaining cards. So they'll pick again. And then from there, if it's the ace of hearts this time, it'll be a $10 discount, and if it's not, they get nothing. Does that make sense? Does everybody get the scenarios? Okay. So what we're going to do is create a probability model for this. Y'all got to work on learning how to do this. First thing we're going to do is start off with defining what our X is, our capital X. X is going to be the amount of the discount. Do y'all get why this is discrete? You're either going to get a $20 discount, a $10 discount, or no discount. Nothing in between, not continuous random variable. Are we good? All right. So I don't have a ton of room here, but the way you write these probability models is like this. I've got X, and I've got probability of X. On the X row, I'm going to list the possible outcomes. This couple is either going to get a $20 discount, a $10 discount, or a $0 discount. That's it. No other choices. Do y'all follow? Okay. Probability of each. What is the probability that they get the $20 discount? So you got to think, how do you get the $20 discount? You have to pick what? The ace of hearts. That's it. That's the only way to get the 20. So how many ace of hearts are there out of how many cards total? 1 out of 4. Or 0.25. You could write 0.25, no problem. Y'all are good? Okay. How do you get the $10 discount? First thing you have to pick for the $10 discount is the ace of diamonds. That's 1 out of 4, right? But then what do you have to do next? You pick again. So we're basically trying to find the probability of ace of diamonds and then the ace of hearts, right? To get the $10 discount. Are these independent events? When you pick the ace of diamonds, is it going back in the shuffle? No. So these are not independent events. So you're going to do the ace of diamonds times the ace of hearts, knowing you've already picked an ace of diamond. You have to change that second probability. What is that going to turn out to be? The second piece. 1/3. Does everybody understand where the 1/3 is coming from? You now only have 3 cards left, and only one of them is the ace of hearts. So together, that's 1/12. Multiplication 1/12. Are y'all following? How do you get a $0 discount? There's actually 2 ways that could occur. So what would that probability be? You don't have to reduce it. You can just tell it to me. It's just 2 out of 4, right? Oh, you're right. I messed up. My bad. Okay, so it's 2 out of 4. plus there is a third scenario, and that is by picking the ace of diamonds and then picking one of the black cards, which would be 2 out of 3. Does that make sense? And what is that? So that turns out to be 2 out of 12 plus 2 out of 4. You could reduce all of that down. Use a calculator. Calculate that if you want. 8/12, which reduces 2/3. Another way of figuring that out is by adding these two together and then just subtracting from 1, if you wanted to do that. Adding these two together and just subtracting from 1, because that's your last outcome, okay? And then definitely do that to check. If you add those 3 together right there, if you add those 3 together right there, do you get 1? So this would be 3/12 plus 1/12 would be 4/12 plus 8/12 would be 12/12, which is 1. Does everybody understand that? Or convert them to decimals if you want to convert it to decimals. Are y'all good? That's a probability model. Boom. Done. Was it too bad? This one took a little bit of probability to figure out the probability. Sometimes you just know them. They just tell them to you in the problem. Okay? All right. What is the expected value for the discount? So that's a formula. It's on your formula sheet. The expected value, or the mean, you're going to take each individual outcome and multiply it by its probability. You don't have to have this formula memorized. It is on the formula sheet. So you don't have to have this formula memorized. It is on the formula sheet. And you just simply get out your calculator and do the problem. Okay? Now what's confusing to you guys, and I get it, is when we get this number, which would be 5 plus 10, 12. $5.83. Remember, this is money, $5.83. When you get this number, it's a little confusing because it's impossible to actually get this discount. Does that make sense? So y'all get a little confused by that. You're like, well, how can that be the average discount? How can I expect that to be my discount? I can't ever actually get that discount. You can't get that discount. The idea is the restaurant has an idea of how much they're going to typically give out. So if they want to think about this in advance, if they want to be like, well, I don't know if I want to do this. Am I going to end up giving out a ton of money and I'm going to go bankrupt? The owner of the restaurant can expect to give out about this much money per couple, per visit. Okay, they're not always going to be that amount, but one couple will get a 20, but the next one's going to get a 0. So it averages. Do y'all get that? So if they have an idea of how many couples are going to dine in there that day, they can get an overall idea, it's not exact, it's theoretical, how much money they're going to give out potentially throughout the day. Does that make sense? So kind of think about that. Nobody gets exactly a $5.83 3-cent discount, but over the long run, remember probability was in the long run, this is what he can expect to give out on average. He is an owner. Well, I don't know why it can't be a she. This is what she expects to give out on average in the long run. Does that make sense? Good. Let's do the standard deviation formula. This is also on your formula sheet. It is your next formula. Now, you need to be careful here. Now, when we were learning standard deviation in the beginning of this course, I didn't do a ton of emphasis on the difference between the standard deviation and the variance. Do y'all remember that in the beginning? A little bit? Probably not. The formula on your formula sheet is this one. This is called the variance. The variance's symbols are sigma squared. Remember, sigma means standard deviation, okay? This says sigma squared. This is the variance. The relationship there is the variance is just the square of the standard deviation. Simple, okay? We use the variance to actually calculate standard deviation. But I'm most probably going to ask you for the standard deviation, not the variance. But you first find the variance, and then what do you do to it? What is this telling me that you do to find the standard deviation? Just take the square root. If the variance is sigma squared, and we want sigma, we just take the square root. Good? Okay? So now he can expect to give out on average $5.83, but that is not going to be the exact amount that he gives out per couple. There is some range of data. It's going to vary. It's not going to be exactly the average. Y'all get that? If there's some measurement of variation, we can calculate that using this formula. And that's what we're going to do now. So he can expect to give out $5.83, but with what standard deviation? This gets a little trickier. You have to take, if you look at your formula, let's go back. What does that formula tell me to do? Let's read this right here. What does it tell me to do? What is X? Each outcome minus, what is the symbol? The mean, that's what we just calculated, the 583. What do we do with that? Square it, multiply by it, probability, then what is that? Add them all up. And then we're not done. That's the variance. How do we get the standard deviation? This means each outcome. So you're going to have outcome 1 minus the mean squared times the probability. Outcome 2 minus the mean squared times its probability. Outcome 3 minus the mean squared. Y'all following? Add all those up. So it's actually, it's easier. You have your calculator, but technically, if I write it all out at one time, it's going to be outcome 1 minus the mean squared times its probability. If I just list it all out. You could sit there and kind of do it all in your calculator. But if we list it all out, is everybody good so far? Okay, plus outcome 2 minus the mean squared times its probability. Plus outcome 3 minus the mean squared times its probability. Add them all up, take the square root. If you don't take the square root, you're technically finding the variance. Take the square root, you're finding the standard deviation. A little lengthy, not all that complicated, but does take a few minutes. If we had a whole lot more outcomes, it would take a lot longer. So you calculate it. Let me know if you get the same thing I'm going to get in just a minute. What did y'all get? I must have messed up. 20 minus 5.83 squared times 1/4 plus 10 minus 5.83 squared times 1/12 plus negative 5.83 squared times 2/3. I think I did something wrong again. I got 8.62. Are y'all good? All right. So we'll stop there. Double check your work. Those are the two formulas. We will pick up where we left off today.